Okay. In Europe, we're hoping to get to Exascale just as you guys are here in the United States, and we obviously heard from a group of people today on the start of your race. The ExaNeSt project is part of EuroExa, which is a group of projects in the European Union aimed at getting to Exascale. There are 4 linked projects which account for about 50% of 68 million euros, and there were a further 5 or 6 European projects previously funded which have led into this. And the objective is to produce exascalable prototypes by 2018, so quite early. The ExaNeSt project is responsible for unified storage, Unimem architecture for the interconnect, mechanical and power for the system, and also cooling, total liquid cooling technology based upon Iceotope's total liquid cooling. It's got 8.6 million euros in funding, which is mostly to 3 partners, but there are a total of 11 partners, some of which from the other projects that collaborate with ExaNeSt. So ExaNeSt is about the infrastructure that the exascalable nodes will integrate into. It's a 3-year project. The nodes are part of a project called ExaNode and are ARM-based nodes. And we're going to be looking at probably having about 1,500 ARM big little CPUs in each blade that goes into this system. So an extremely dense solution. Iceotope was selected because we can cool 3-dimensionally. And one of the key factors of this is the stacking of small low-power processors, the stacking of memory, and the reduction of the distance in which you've got to transmit data to gain extra energy efficiency. Many of the people in the room thinking about Exascale will know that PCI Express by itself will blow your Exascale power budget, so something has to change. Isotope's also safe and efficient. Unlike other immersion technologies and historic immersion technologies, we've cracked the PFIB problem. And we believe that that will allow immersion to become the cooling technology for the future. We've got systems that we've deployed which have demonstrated very high inlet temperatures and heat capture capability. 50% of the systems we deployed have captured heat and used it to heat up labs. We're very, very high density, and we're low cost per watt when you start scaling the electronics up. We're a total liquid cooling technology. We have existing technology demonstrators, but the magic really comes when people start looking at designing electronics to go into immersion and liquid cooling environments. But people can get hold of our technology today with normal x86 components in order to look at trialing, testing, measuring, and designing for the future. The output of the ExaNeSt project in 2018 will produce a system which, when scaled, will consume 60 megawatts of power, 1 byte per flop of data, 1 exaflop of compute capacity. It'll have 18.5 million ARM CPUs, 37 petabytes of RAM, 1 exabyte of flash virtualized storage, and be in less than 200 cabinets. It's ambitious, but it's also known and realistic. So that's the end of my presentation. Over to questions.
Thank you. So Peter, briefly, there have been other immersion technologies, the KFC machine, TAC had their machine. Oil's messy, but tell me the benefits of your technology.
So we use a liquid fluoroplastic as opposed to an oil. It has a very, very low surface tension, a viscosity half that of water, and it has a very, very high thermal expansivity. So it convects by itself. It moves the heat around through natural convection as opposed to requiring pumping. And that allows us to have a very, very small failure domain. We can have a failure domain of a single blade. So a single blade with the coolant inside. And that also allows us to minimize the coolant volume because these coolants are expensive. The other enabling factor of that is around safety and how we overcome the PFIB problem of historic items like the Cray 2.
Very interesting project. I hope to hear more about it in the future. Do you have any prospects in the traditional OEM market for your cooling technology?
We're very interested in openness in terms of the future of this technology, and obviously wouldn't be in a position to discuss any ongoing engagements, but we're very interested in openness and interested in working with people in the future on these technologies.
Very good. Thank you.